Alright, 1C, relations and functions, and we're actually going to pause right here, right at the beginning, because this should be a review for you labeling axes and quadrants. So I want you to pause here and do these 5 questions in your notes. Label those things and then plot the ordered pair. Okay, so maybe without the cool colors that mine has, but hopefully you were able to label these things correctly. The x-axis is the horizontal axis. This green one, the y-axis is the vertical axis. When we label the quadrants, quadrant 1 is at the top right, okay? And we do them with Roman numerals, and then it goes counterclockwise. So this is 1, this is 2, this is 3, this is 4. The origin is right here, it is 0, 0. And then you had to plot the ordered pair 2, 3. So the x-coordinate is first, is 2. The y-coordinate comes second, it's 3. So I went to 2 on the x-axis, and then up 3 on the y-axis, and that right there is the point 2, 3. So that was just a quick review on the coordinate plane and graphing things. And now we're going to look at relations. So a relation is just a set of ordered pairs. Anytime we have more than one ordered pair, that becomes a relation. And we have 4 different ways that we can represent a relation. It's a set of ordered pairs, so of course we can represent it with ordered pairs. So I just came up with 4 ordered pairs here that these are my relation. We can also write these ordered pairs in a table. We can plot these ordered pairs on a graph, and we can put them in what's called a mapping. So if I have ordered pairs in a table, in my table I have one column for the x values, one column for the y values, and the x and y value that go together are next to each other in the table. So I just copy exactly how they are written, the values into the table. Alright, if I graph them, of course I'm going to plot these points. So 1, 3, 2, 4, negative 2, 3, and 0, negative 1. So I just draw a plot. Okay, when we have a mapping, we put the x values in one circle, the y values in another circle. Usually we're going to put these in numerical order. So if I look at all my x values, negative 2 is the smallest one, and then it goes to 0, then 1, and then 2. And then in my y values, my smallest y value is negative 1, and then I have 3. Now that 3 appears twice, but I'm not going to write it twice in the mapping because I'm going to end up drawing arrows. So I'm only going to write 3 once, and then I also have 4. Then for a mapping, you just draw an arrow between the points that are connected. So negative 2 goes with 3, so I draw an arrow. 0 goes with negative 1, so I draw an arrow there. 1 goes with 3, so I draw an arrow to 3, and then 2 goes with 4, so it gets an arrow straight across. We can also use an equation to represent a relation, so I could say like 2x plus 4 is a relation, and then I would have my different x and y values to make ordered pairs. Then a function is a special kind of relation. So in a function, there is exactly one output or y value for each input or x value. Alright, another way of saying that is that the x values cannot repeat. Okay, so if I have as one of my inputs or one of my x values, I have 2. And then the y value that goes with 2 is 5. Then I cannot later on in my set of ordered pairs have another 2 as an x value and then 7 as a y value, okay? Because then that x value has 2 different y values that go with it, and that would make it not a function. Alright, so depending on the way that our relation is represented, there's different ways to determine if it is also a function. So if I'm looking at a set of ordered pairs, or if I'm looking at a table, I'm looking for repeating x values. If there is an x that appears twice in a table, it is not a function. If there's an x that appears twice in a list of ordered pairs, then that relation is not a function. In a mapping, we're looking for, does an x value have arrows going to more than one number? So if I have 2 in the x circle in a mapping, and it has 2 arrows coming out of it going to 2 different numbers, that would not be a function. If you're looking at a graph, we're going to do something called the vertical line test, and I will show you exactly what that looks like when we get to those examples at the bottom. But you're looking for a vertical line to only touch the graph in one spot at a time. Okay, so let's look at some examples. Alright, the first thing we have here is a mapping. And see, -4 only has 1 arrow, -2 only has 1 arrow, 0 only has 1 arrow, 2 only has 1 arrow, and 4 only has 1 arrow. So yes, this is a function because each x value only has 1 arrow pointing to a y value. Now, if you look at the y values, there are 2 arrows pointing to -1, and there are 2 arrows pointing to 4. That is okay. Y values are allowed to be repeated in a function, alright, but x values cannot be repeated. Over here we have a table, and I'm looking at the x values, 2, 5, 6, and 6. The 6 is repeated, and look, it has 2 different y values, 6, 9, and 6, 10. That can't happen in a function, so this one, no, is not a function. Here I have a list of ordered pairs, so let's look at the x values. I have 2, -1, 5, and 2. Well, that 2 appears twice. That is not allowed in a function, so no, that one is not. Okay, we're going to skip the line for now. We'll do that in a later chapter. Okay, now we're going to look at some graphs, and here's what I mean by the vertical line test. So I have this straight up and down line. You might want to take your pencil, set your pencil up, and run it across the graph. So if I move this vertical line across the graph, where does it touch the blue? There, it only touches 1 blue dot. There, it only touches 1 blue dot. Here, it touches 2 blue dots at the same time. This one up here, and this one down there. That means that this is not a function, okay, because it touches a vertical line in 2 places at the same time. Right, here's why the vertical line test works. If I were to write the ordered pair for this dot, it is at 0, 1, 2, 3, 4, 5, 6, 0, 6. The ordered pair for this dot is at 0, 1. So that means I have 2 of the same x value with a different y value, which is not allowed. Okay, so the vertical line test, if it touches in more than one place at a time, it is not a function. Alright, now we'll look at this example. I'm going to take my vertical line and just slide it along, and everywhere it's on the blue, make sure that it's only touching at one spot. So this is one spot, one spot, one spot. It's only touching that blue line in one place all the way across. So that means that this graph, yes, this is a function because the vertical line only touches that blue graph in one spot at a time. So what I want you to do is try 7 and 8 here. Just take your pencil and use it as a vertical line, run it straight across the graph, and see if it touches in more than one place at anywhere on the graph. All right.